Hello, and thanks for joining our talk today. My name is Andy Nichols, and I'll be your host for our presentation of the new features that have been added to Qt version 6.4 for Qt Quick 3D. Here's a quick overview of the new features we will cover. For the first four topics, we'll have each developer give a more in-depth talk about their particular feature, and then we'll end with a short demo of some of the other new features not covered more in depth. The first topic today will be reflection probes, presented by Hatem.
Hello everyone, my name is Hazem and I've been working on the reflection probe for the Qt Quick 3D. The reflection probe was introduced in 6.3 as a tech preview and was fully released in 6.4, and it's the way to do reflection in the Qt Quick 3D. The reflection probe, you can imagine it as like a box. The box has a camera in the middle which captures the scene from 6 different directions and store it in a cube map, and the model inside this box can use a cube map to display reflections. To accommodate for the reflection probe feature, the model QML component has two new properties: received reflection and cast reflection. And as the name implies, the received reflection says, does this model receive reflection from the reflection probe or not? And cast reflection, it means, does the reflection probe capture this model in its cube map or not? Finally, the reflection probe can be used in Qt Design Studio. When you're developing your application, you can fully use it. And today I have a quick demo to demonstrate the feature of the reflection probe. In this scene, we have some flying objects with a green sphere in the middle and a reflecting surface. We have several properties for the reflection probe to control it. One of them that's very handy is a debug view, which visualizes the box of the reflection probe. When you're rendering your application, the green sphere is just there. I put it to visualize the capture point or the camera of the reflection probe, where does it capture the scene. We can move the reflection probe around using the position property in the node QML component. As you can see, I'm moving the probe around. And we have the box size property, which control how big the reflection probe box is. And as we said before, any model lying inside the reflection probe will display reflections from the probe cube map. So the box size affects what's included in the reflection probe or not. Finally, we have the box offset property, which basically moves the box offset with the box itself without moving the capture point. And sometimes it's like very handy to have like a separate property to control the box position from the capture point of the probe itself. We have some properties to control the quality of the reflection probe itself over here. We're going to talk about them. As you can see, if we just like like this, as you can see, we have reflections on the surface here. We have the refresh mode, where we can control, do we have a static reflection or dynamic reflection. If we choose the first frame, the scene is captured only on the start of the application. We can turn it to every frame where the reflections are casted dynamically. We can control the reflection map quality from very low to very high. Medium would give us much more better reflection over here. Moreover, we have like the parallax correction, and this property correct the perspective errors in the reflections appear on the surface. As you can see, like the captured cube map have perspective errors, and we can use parallax correction to display object in their correct sizes. And we can control this like by increasing the box size. And now, if you can see, we have much more better reflections. And this property takes account into two things: the position of the receiving reflections of the model, this surface, and the box size itself. Finally, we have the time slicing property, which has three options. A none option, which means like all the faces of the reflection probe plus map maps are rendered and filtered in the same scene. As we said, the reflection probe is part of the physically based rendering pipeline. So we need to make filtering for the map maps of the reflection probe. So none will capture the six faces and do the filtering in the same frame. All faces at once will capture the faces in a single frame and do the map maps in subsequent frames. Finally, we have individual faces, which means we capture each face plus do the pre-filtering in the same frame. So each face is like updated every 6 frames. So by these like properties, you can control the quality of your reflection probe. I hope this demo was helpful for you guys, and I hope you play around with the reflection probe. And if you have any question, please write them down, and I will try and answer them. Thank you very much.
Thank you, Hatem. The next presentation is about the new physics engine in Qt Quick 3D. Here's Jonas to tell you more.
Hi, my name is Jonas Karlsson and I will be presenting the Qt Quick 3D Physics module. This is a new module since Qt 6.4. It's released as a technical preview and it adds physical simulation capabilities on top of Qt Quick 3D. So you can, instead of having to handcraft animations, you can have physically realistic behavior to your 3D scene. So this module adds supports for rigid body dynamics, which is physical simulation of rigid bodies. And with this, you have support for setting the mass or density of objects as well as friction. And we support a bunch of primitives built in, like spheres, boxes, planes, and capsules. And also, of course, convex and triangle meshes, as well as height maps. So you can pick and choose what you want to simulate. And we also have bodies which can interact dynamically or statically. So you can have a box that can bounce around, or you can have like a ground that's always static. As well as trigger bodies, for instance, you can have an area where if another body overlaps with this area, then you can trigger some kind of action you want. And this is a pure QML module, so it's everything using QML, and it builds upon the Qt Quick 3D module. And yeah, so let's look at an example. So this example is called Simple, and it's one of the built-in examples provided by Qt Quick 3D Physics. And as you can see, you have a window as usual, in as you would in a quick 3D scene. What's new is probably this first thing called Dynamics World. This is where you have to define this to define the physical world, and you can, for instance, decide if toggle if it's running or not, and other properties of the whole dynamic world. Then we have a view 3D. And in this view 3D, we have the typical scene environment, perspective, camera, and light, just to have a scene, basically. And here we add the first physical thing, which is a static rigid body. And a static rigid body is a body that's static. It does not move around or interact in a reactive way. So kind of like a ground or something like this. And in our case, we define a collision shape, which is a plane shape, and then also a model for this. So this is going to be a plane on the floor. Then we add 3 dynamic rigid bodies. The first one is a box, so it has a collision shape as a box. The second is a sphere, and the third is a capsule shape. And all these have proper corresponding model as well. So let's run this scene and see how it looks like. So this is how it is. It's a box, a sphere, and a capsule. So it's quite simple to make a very basic scene. So let's look at a few more examples to see what you can do with physics. This is another example where you can modify friction and stuff like this. So as you can see, when the sliders change, then also the behavior of the box changes. And this is another example where you can combine shapes. So you have yeah, you can make rings like this. And this final example is just combining animation and spawning and moving objects like this. So yeah, that's basically it from the physics module. So yeah, feel free to try it out, and thanks for watching.
Thanks, Jonas. Next up is Laszlo to talk about indirect lighting and global illumination.
Hello, I'm Laszlo, and it's time to talk about global illumination in Qt 3D. What I'm going to do here is quickly showing a simple example that is demonstrating some of the new features in Qt 6.4. So let's get started. Here I have a Qt application that has a 3D scene in it. The 3D scene has, unsurprisingly, a camera, a single point light. The light is casting shadows, and there are two imported models in this scene. Both of them are probably pretty well known. So one of them is a variant of the Cornell box model, and the other one is known from Blender. If we run this, there are no surprises. It all looks as expected. The interesting part now is that this uses real-time direct lighting, and also the shadow maps are generated real-time. So if I trigger a rotation on the model, the shadows will move as expected because we regenerate the shadow map for that point light. I can also confirm this using this new enhanced debug view, which is, by the way, an upcoming feature. So if you are familiar with debug view, you probably know that in older versions this shows a lot less information, but it's going to be expanded actually. So it's gonna show a lot more interesting information in the future. So if we take this render pass list, for example, which shows the render passes from the last frame, we see that there's a lot of shadow map related steps there. So these are all render passes that were needed to update, to generate that cube map, so the shadow map for that point light. By the way, I can also use this debug view to visualize a few things. For example, let's just see what are the base colors in this material. So I'm showing this that the red and green walls, which are going to be interesting to us. So the color of those is coming from the material. So there is a base color is probably set to red or green. Of course, it could also come from a texture map if you use the base color map property instead. So what I'm getting at is that there is nothing wrong with this, but the lighting in this scene is not very realistic. So why is there no, red or green on the surface of this object? So in real life, of course, we expect light to bounce off objects and then illuminate other objects, depending on the material. And this scene only has direct lighting. There is no simulation of indirect lighting. So how the light would bounce around in the scene. For that, Qt 6.4 introduces a simple static GI solution based on pre-baked lightmaps. If I click this checkbox, we get this, and oh, suddenly the scene looks much better. And yeah, it looks like there is some indirect lighting in there. Maybe it's a bit exaggerated even. So this is configurable, so there are some options to change. So the designers can tune this if they want to. And what we see here is that we have much better looking shadows. The lighting is also more realistic. I don't know how visible that is, but for example, it has proper occlusion in the sense that it doesn't really travel through walls, which is it can be a problem if we just do the real-time calculations. Whereas here we get good-looking shadows, proper occlusions, and of course indirect lighting, because this is all done using ray tracing offline. So in the list of active textures, I can see some new texture maps that got loaded. So these are floating point textures. So these are the light maps, which are then applied on the objects. And we do this instead of doing the diffuse lighting calculations in the fragment shaders. And also, we don't need to do the real-time shadow mapping, since the shadow is baked in. So this is now only a single render pass, which might be actually good for performance, especially on the systems and devices that are not so powerful. So this can be a lot cheaper compared to real-time shadow mapping. It does have some downsides, of course, since this is a static baking-based solution. If I trigger a rotation on that model, well, we can see the shadow is not moving and the lighting on the surface of that model is not entirely accurate anymore, since it's baked, it's using the same light map, it cannot change. So the story here is that it will be basically up to the designers to decide which approach to use and when. So for each scene, some objects will probably want to use bake lighting, so the static objects that don't really move. Whereas some objects, the ones that are more dynamic, they will probably want to use real-time lighting. And to finish this off, I might quickly show how to bake a light map. So this is currently in a technical preview state, so things may change in later versions. Currently, what we can do is launch an application in Lightmap baking mode, and here lots of things are happening. It can be followed by reading those logs, and the result is that, basically a bunch of assets which will need to be shipped with the application. It's usually a good idea to run a denoising step, so here I'm using one of our tools that uses open image denoise under the hood to really make the light maps better looking. And that's it. Then the light maps are basically shipped with the application and used during the normal run. There are a lot of new things in the API regarding light maps. Well, not that much, but if you check, for example, the documentation for the light type, you will see that it now has a bake mode property in Qt 6.4. Or similarly, the model has things like bake light map or used in bake lighting, which controls that does this model participate in bake lighting or not. And finally, if you are interested in this, I can also recommend your new topic page. So this is under the main Qt 3D documentation page. So there's an introduction there which describes what you can currently do with Qt 6.4 when it comes to global illumination and light baking. This is expected to improve in the future, so I see this as a step on a longer journey. So we are actually looking into other approaches to GI as well. So it's not unlikely that we will get some more dynamic solution in the future. But Qt 6.4 already makes a good step forward. So there is now basically indirect lighting, some form of indirect lighting, which I think is excellent news.
Thanks a lot, Laszlo. To finish off the developer topics, here's Christian to discuss the new custom material editor.
Hi, I'm Christian, and today I'll be taking a look at the custom material editor in Qt Quick 3D. For those not familiar with the custom material type, it's our more advanced material that allows you to write and inject custom shaders for the vertex and fragment stages, and with that, control how the material is rendered. The custom material type comes in two flavors, shaded and unshaded. The main difference between the two are how the material sees the scene and how much of the rendering you want to take control of yourself. For example, a shaded custom material will still get lighting contributions to its output, even if you decide to override the base color of the material. This is in contrast to the unshaded mode, where you would need to add in these calculations yourself. Since the process of creating a custom material involves writing shaders and exposing uniforms and properties, we added the custom material editor, which should make the process of creating those materials easier and more iterative. The custom material editor is a standalone tool and ships with Qt Quick 3D. It has real-time preview of the material, syntax highlighting, and error reporting. So let's just dive in and see how we can quickly create a custom material and use it in our Design Studio project. So here we see a greenish sphere, which is the base example code when you open a new Qt Quick 3D project in Design Studio. But let's make it a bit more interesting by writing our own custom material. If your kit has the custom material editor available, it should be visible under Tools, Modules, Qt Quick 3D. So let's launch that. And this is how it looks. On the right side, we have a preview of a model. And on the left side, we have the vertex shader and the fragment shader. These are code editors, and the language we are going to put in here are a Vulkan style GSL shader type. Variables and overridable functions that are specific to Qt Quick 3D are all in uppercase. Full list of available functions and variables can be found in the documentation for the custom material type. So let's just start writing some shaders. I'll start by creating a vertex shader. We're going to make a vertex shader that modifies the Y position of the vertices. So first we need a main function, again, all uppercase. Then gonna modify the vertex Y position. And as you can see, the shader compiled fine, and you can also see the effect on our model here. Now let's do a fragment shader. For this one, we're just gonna modify the base color. Let's make it red. And as you can see, we get a red sphere in our preview. Now, once we export this, we probably want to be able to modify both how dramatic the change is to the vertex position, but also the color. So let's add some uniforms for those. I'll call that U factor for the vertex position. And then I'll add like for the U base color. Now we need to add those into our shaders here. So instead of the hard-coded value, let's use U base color. And that turns out black because there's black colors. Let's just set that to green now. And we can see that immediately showing up here. And let's do the same for the vertex shader. Let's add in the factor. And now that looks completely round, since that's the default value for that is 0. So let's make that 10. That's a bit much. Let's adjust it down slightly. There. Now that we're happy with the material, we can go ahead and export it. So we go to File, Export. We need to give the component a name. Our project is already selected, so we can just put that in the content folder. I'm going to call it My Material. Save. You'll also be needing to give both the vertex and fragment shaders a name. I'm going to keep that simple, vert and frag, and export. And now we can see that the component showed up in Design Studio. So let's just drag that onto the model and see how it looks. And as you can see, that looks pretty much like it did in the editor. But what we also can see is that on the right side in the Design Studio's material editor, we see our uniforms now exported as properties. So we can actually change these values from Design Studio as well. And that's all I had. Thanks for listening.
Thanks, Christian. As promised, there are many other features that were added in 6.4 to Qt Quick 3D. Here's a short demo highlighting some of those new features. I hope that this demo, as well as all the great talks today, served as an inspiration for you to go out and try these new features for yourselves. It's been a pleasure being your host today. Thanks for watching.